Today's video is about sample space. Our learning target today is when given a description of an experiment, I can list a sample space. What is a sample space? A sample space is a list of all the possible outcomes to a probability experiment. Please pause the video if you need a moment to copy the definition down. Sometimes a sample space is easy to figure out. Sometimes a sample space gets a little more complicated, especially when we have more than one event in our probability experiment. That's called compound probability, and that's what we're talking about today. Let's take a look together at number 1. It says, an experiment consisted of flipping a nickel and a dime. List the sample space and each probability. So let's first think about flipping the nickel. When I flip a coin, there are 2 possibilities. For the nickel, I could get heads or tails. So if I list the sample space of just flipping a nickel, there it is, it's heads or tails. But now we're looking at 2 probabilities together. We're talking about flipping a nickel and flipping a dime. So we're going to kind of think of our sample space like a tree. So the first step that happens is that I flip my nickel, and it gives me either heads or tails. Let's pretend for a second that I got heads for my nickel. For my dime, I still have 2 possibilities. I could either flip my dime and get heads, or I could flip my dime and get tails. The same thing could happen if I got tails on my nickel. If I got tails on my nickel, I could get heads on my dime or tails on my dime. So if I'm flipping these 2 coins, each one has a sample space of heads or tails. But if I look at their sample spaces together, the possibilities that I could get are heads on the nickel and heads on the dime, or I could get heads on the nickel and tails on the dime, or I could get tails on the nickel and heads on the dime, or I could get tails on the nickel and tails on the dime. So all in all, even though there were 2 possibilities each, there are 4 possible outcomes. This is our sample space. The probability of each one of those outcomes is 1/4. There are 4 total outcomes, or 4 possibilities. And right now, we're working with possibilities that are all equally likely, right? Half the time on the nickel, we're going to get heads. Half the time on the nickel, we'll get tails. Half the time on the dime, we'll get heads. Half the time on the dime, we'll get tails. Half the time on the dime, we'll get heads. Half the time on the dime, we'll get tails. So those probabilities are equally likely. Therefore, the probabilities for our compound probability are all equal as well. So the probability of heads and then heads is 1 out of the 4 possibilities, which is the same as 0.25. That will be the same for all 4 of these outcomes. Something we might notice is that if I add up all these probabilities, they add to 1. If I add 1/4 4 times, it gives me 1. The same thing will happen if I add 0.25 4 times. Or if I think about it as a percent, that'll be 25%. And if I add 25% 4 times, I get 100%. So the sample space I've listed a couple times. I've listed it in the form of a probability tree, and I've listed it by just outlining my outcomes. I could have also listed my sample space using curly brackets. So I could have said heads, 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 tails, tails, heads, tails, tails. They all mean the same thing, so it really just depends on your preference. I happen to like the tree best because it lets me see the path of probabilities of possibilities, right? I could get heads and then tails, etc.